Hi there, my name is Alan Hong, Strategic Marketing Manager here at Thoracic Technologies. Today, I will be showing you how to set up your first FPGA design using Verilog coding. Over the course of this tutorial, we will set up USB blaster drivers, write some short Verilog code, and assign pins to their specific locations. We'll be implementing a simple counter on our red LEDs. For this video, I will be using Quartus 9.1 Service Pack 2. So, here we can see our DE2115 platform. To get started, please first plug in your power supply here at this port. Also, plug in the USB cable in the blaster port here. Make sure that your Run program switch is set to Run. Now plug the other side of your USB cable into your PC and turn on your board. So now that our DE2115 board is plugged in with the USB in the USB socket and the other side in the PC, we're going to have to install our USB blaster drivers. Now we'll go over to our device manager, and over here we can look down to see that our USB blaster driver is not recognized. We'll double click on this icon and we'll go over here to update our drivers. So now we can click on Browse My Computer for driver software. If we installed Quartus correctly, then we should be able to find the drivers inside the driver software folder. So we'll do that by going to Browse, and for your computer, this should be wherever you installed it. So over here, I installed it in my C drive. Scroll down and go to Altera and click on the version that you're going to be using. For me, it will be 9.1 and Quartus, and the drivers folder should be in there with the USB blaster folder here. So we'll click OK, click on Next, and it should find it automatically. Would you like to install this device software? We'll click on Install. Now it's successfully updated your driver software. You'll see that it says Altera USB Blaster. We'll click on Close, Close, and you'll see that it's updated right here in your Universal Serial Bus Controllers. We can exit that now. So now let's open up our Quartus 2 software. Quartus 2 is the primary IDE for coding your RTL designs for all Altera FPGAs. So over here we have our opening window, and we can click on Start Designing by clicking on Create a New Project. So here we can see that there's an introduction, and we can click on Next. And the first thing we have to specify is what is the working directory for this project. We'll specify it in our C drive, and we'll create a new folder, My First FPGA. Next, we're going to specify the name for this project, also called My First FPGA. And your top level entity will be the same name, My First FPGA. We can click on Next, and it will tell you that the directory My First FPGA does not exist, and do you want to create it? So we'll click on Yes. And right now, for this one, we can specify which specific Verilog files or other design files that we want to add. We have none so far. We'll skip this for now. And here we can click on our device family. So since we're using the DE2115, that's going to be a Cyclone 4 FPGA. So we'll go down, we'll go up to click on our Cyclone 4E, and since it's a speed 7 115 K gate, we can click on our specific number, which would be the EP4 CE115F29C7. If you're not sure about this, you can also go look on your specific FPGA. It will list it right under the Cyclone 4 trademark logo. So we'll click on Next, and we don't have to touch any of this for now, and we'll click on Finish. So now we're set up with our IDE, and over here you can see that our Cyclone 4 device is over here, and our top level entity, my first FPGA, is over here. And this is our project navigator. We'll be using this to navigate through our project. And down here we have a status window which will specify our status during our compilation times. And we also have a console window down over here. On the top right, this is our main window for editing. So we'll click on New over here to specify a new Verilog file. And we'll click on Verilog HDL file. Click on OK. So now an editor has appeared for us. So this editor is going to be our top level module. And we'll start out by specifying our module name. Module my first FPGA, parentheses. And we'll start out by declaring our specific pins. So that will be our clock, which runs at 50 megahertz. So we'll do clock underscore 50. Next we have our LEDs. We're going to use 4 red LEDs. So we'll specify that as LED R. And next and last, we're going to specify our key, which is going to serve as our reset button. So now that our module is declared, we can start specifying our input outputs. So we'll put a comment here, input, output, declarations. So first we have our input, clock, 50. We also have our input reset key. And our outputs will be our red LEDs. And we'll specify a specific array. So over here it's going to be a 4-bit array for our LED Rs. So now that our input-output declarations are complete, we want to specify our reg wire declarations. So reg, we're going to implement a counter, and we're going to implement one that is 28 bits wide. Count. Now for our structural coding. So our key is going to serve as our reset. And since all of our keys, our push button keys on our DE2115 board are active low, our reset is also going to be active low. So we're going to assign reset n equals key. Sorry, I also have to specify that our reset n is a wire. N. Okay. And now we're going to have an always statement. So always at pos edge, which is the positive edge of our clock 50, or neg edge of our reset, and we will begin if our reset n is negative, our count will reset to 0. Else, our count will equal to count plus 1. And we can end our always statement there. And now since our clock is operating at 50 megahertz, we have to specify our LEDs R as equals to the most significant bit of our count, so that we can actually see the counting in action. So that's all of our coding for now. And we'll end it by declaring end module.